All right. Welcome once again to the spring series. I think we're on session number 4 with 2 to go. Tonight we have Christopher Meek from the University of Washington. I'll give him a little more intro in a minute. Thanks for coming, both in the room and online. If you're online, it'll be emails to Tristan V tonight for questions, and please don't hesitate to email questions in. Thanks, as always, to Better Bricks, to the Northwestern Energy, and to Idaho Power Company for sponsoring tonight's event. Let's see, upcoming events very quickly. The next lecture is May 7th, Office of the Future by Doug Avery. There is some question on whether Doug's going to be able to make it, actually, because of some travel rules with the state of California. So we'll keep you posted through the regular channels, but just make sure that you check in before you show up. We're working on a replacement in case Doug doesn't work out. And also, if you haven't seen it around town, there's a whole bunch of excitement over Hunter Levin's coming to town on April 30th. So that's very soon. With that, I'm going to turn it over to Chris. Chris Meek was a colleague of mine, I guess, is still in some ways. We worked together at the lab in Seattle for a couple years. I learned everything I know about daylighting from Chris. He's one of the most active daylighting consultants in the Northwest, certainly, probably in North America, and who knows beyond that. So he knows his stuff about daylight. Don't go easy on him. Lay in, ask lots of good questions. Thanks for coming, Chris.
Thank you. Yeah, thanks to Nia for funding me to come out here, and thanks to Kevin for inviting me, and thank you to all of you for being here. My talk is really sort of 3 parts. One is just an overview of why daylight is important, and then I'm going to go into some design strategies, and then look at some projects that we've done recently that I think are pretty successful. The talk I'm giving is loosely based on a talk that I've been giving recently that's a little longer than the time period that we have now, so I'm going to go pretty fast. Feel free to interrupt me, shout me down, call me names. Don't hesitate to stop me if you have questions or want to take issue with anything that I've said, because most of the things that I've learned have been from people strongly taking issue with things that I think. So I always like to start off a talk that I give with an image like this. And there's been a lot of talk around daylighting. It's something that's sort of become interesting again. But we shouldn't kid ourselves that this is something new, and that, in fact, architects were responsible for delivering functional illumination to spaces forever, until fairly recently. And that through spaces like this is the National Library in Paris, designed by Le Brouste in 1868, we can see that architects have in the past been masters of using light to deliver high quality spaces for people. You can see the aperture relationship to the surface, the structure, the form, the basic building geometry, and ultimately the space at the bottom that people inhabit and are able to function for the whole purpose that the building was built. So this is not something new. It's something that we as architects sort of know, but have kind of forgotten recently for a number of reasons. And the window was really, for a long time, the primary building system for delivering light, air, essentially making spaces habitable. And we can see this is an image from Manhattan in the late 1800s. This building, where the sort of basic building geometry and the windows provide light, provide air, again, making this space functional. Without the window, this space wouldn't be habitable, it wouldn't be comfortable, it wouldn't serve its purpose in any real fundamental way. And you sort of look at buildings like this. This is kind of a run-of-the-mill office building, though I'm a big fan of Albert Kahn, industrial architect. This was one of his office buildings, and if you look at the building, its sort of fundamental basic geometry rolls out of the way that it addresses light. What we see is the ground floor. This is General Motors building, so the ground floor is a big automotive showroom. Maybe this isn't the most topical company to be holding forward as a paragon of virtue, but what we see with this building, this was state of the art at the time, The entire block was covered with this auto showroom. Big windows, very tall floor-to-ceiling section, and then the upper floor was all executive offices. And the architect here knows that there's only a certain distance. By virtue of the physics of light, there's only a certain distance that you can deliver light into a space, and it's pretty close to the perimeter. There's also only a certain distance that you can ventilate a space, and it's pretty close to the perimeter. So what do we see? We see a building that's essentially all perimeter. To make this space work and function, everything had to be within 10, 15, maybe 20 feet of the perimeter zone, and that's exactly what they did. That's the basic fundamental structure of this building floor plate, and it works pretty well. You'll notice that there's also a relationship between the distance of these bars that has to be maintained, lest the daylight distribution in the lower parts of this building section be interrupted and those spaces not be functional. And then in the deep section, this is a plan of the ground floor. What do we see? We know that this is deep, and the challenge with a deep floor plate like this is you can't bring in light from the perimeter to effectively illuminate that space. So in that space between the office bars, what do we have? We have a set of skylights that essentially illuminate the back of this showroom to supplement the light from the perimeter. It's not rocket science, but it's a very thoughtful integration of building form and light. And secondarily, these skylights, by illuminating the back of this section, allow for a nice transparency through this. Otherwise, you'd be in a very bright exterior looking into a very dark interior, and that window would have been reflective. But with the addition of the skylights, you can see those products highlighted in that space beyond you. So this is very functionally about lighting design and the way you experience space. Secondly, the way that this building was programmed looked at the relationship between the needs of each one of these program elements and the distribution of daylight into the space. And we'll see the offices are important, the showroom is important, these sort of shops are important. But this entry lobby and elevator area, not so important, because what the architect wants you to do is sort of enter this space and have your eyes adjust to low interior light levels. And then when you get to your destination, it feels bright, rather than just going into a space that's immediately darker than what you exited. And ultimately, this space here, the auditorium, which is probably the space that needs the highest level of luminous control, because they're using spotlights, doing theatrical stuff, is buried in the center of the building. They don't want daylight in there. It's not going to fit with their sort of programmatic needs here. So this is sort of a simple building, but it's very elegant and thoughtful in terms of the way that it addresses light. And this was basic competence for architects up until about 1945-50. And it was so key that architects really took this stuff seriously. This is a section diagram of a welding shop for the Ford Motor Company. And there's some basic analysis about how diffuse illumination enters the space, how air flows through. And the architects took this stuff seriously because if this stuff didn't work, their spaces wouldn't be habitable, they wouldn't be functional, they wouldn't serve the purposes that they were designed to do. And you can see that the desire for getting functional illumination across this floor has a relationship to the way this section ultimately sort of rises up out of that work plane and meets the sky or the apertures. And one of the main reasons for that is because back then, one, they didn't have a very reliable electric grid, and two, they didn't have very good quality electric light sources. They were using gas lamps. And when they built buildings, this is a finishing shop here. You can see that there's a lot of glass. It's very carefully considered to effectively light this space because there really isn't electric lighting. They needed to rely on this daylight. This is a finishing shop, so they wanted to be able to see the light modeled around these vehicles on all sides so that they could effectively do their work. And not only did it have to function on its own, it had to function across a really broad cross-section of the day. Because if there wasn't enough light in here, these guys couldn't work, their product would be substandard, and it was really, really taken seriously. And we see these industrial buildings. I'm just in love with them because they're cathedrals of light and just show a can-do optimism that we had at the time. And buildings like this sort of proliferated and served us for a very long period of time until about 1940. And what did we see after World War II? We started to see buildings that looked like this. And what enabled buildings that looked like this was fairly low cost of energy and the emergence of some pretty high quality lighting technology. But in an effort to efficiently deliver functional space, I think something was lost, and most of you who are architects and look at images of spaces like this would probably agree with me. And what really happened was that the relationship between how architects designed their spaces really lost connection with light in space. And that work became the purview of lighting designers and engineers. And those things sort of went their separate ways. And I think only now they're starting to work their way back through integrated design, kind of like the things that are being promoted here in Kevin's lab. And we saw buildings sort of like this all the way through the late 80s. This is Michael Graves' Portlandia building. It's sort of an easy target. And this building was commissioned because it actually won an award based on energy efficiency, or it was chosen based on its energy efficiency. And can you guys imagine why this building might be so energy efficient? Yeah, it basically doesn't have any windows. It's just a big box. And there was sort of this idea that if we can design systems well enough, we really didn't need to have a connection to the outside world. We could sort of do our own thing and be okay. But it's very, very difficult to escape the side effects of that kind of thinking. And we're seeing a return to daylight, certainly a return to looking at climate in terms of the way we design for a wide variety of reasons. We know that daylit environments are healthier, and I know Kevin has talked to you guys about this in the past. But I think it's always important just to remind everyone that we're sort of in a very, very long-term experiment with ourselves that we don't understand very well. If you look at the pattern of illumination that we were exposed to, sort of high levels of brightness and very, very dark environments, sort of the night-day cycle. And we evolved, our brains evolved under that influence. You see here our sort of ancestral pattern of luminous exposure. It's very dark. In the morning, the sun comes up, and midday, it gets really, really bright, and then ramps back down. But nowadays, what we do is we're in interior environments most of the time. And at night, we're in sort of low light levels, our houses, our TVs, interior spaces, and we're sort of cruising along at 10 or 20 foot candles. And we might get up, head out to the car or the bus stop, catch the bus, drive into work, get a little dose, and then we sit at about 50 foot candles in our offices, or 30 or whatever it is. And then ramp up for our little trip to lunch, back in the office, 30 foot candles, and then back home to our sort of low light level interior environments. And that's very, very different than what we've become, what we were built for. And not only do we sort of not get the brightness, we don't really get the darkness either. We have the ability to illuminate everything all the time, and we sort of do that for a lot of reasons. But and anybody who's flown into a city at night just knows it doesn't seem right to light everything, especially when no one's there. But we do it anyway. We also know that Americans spend 90% of their time indoors and tend to work more hours than any other industrial nation. And that light regulates our brain chemistry, serotonin, melatonin, based on just not exposure to light, but just seeing brightness. Seeing that brightness tells our brain it's time to wake up. And as architects, it's key that we address that. The circadian rhythm is sort of how our body responds to the 24-hour cycle of lightness and darkness. And also the color spectrum, sort of dynamic chromacity of the sky, or the way it changes color, the way it's blue during the day and much warmer in the evening. And the disruption of that cycle can lead to all kinds of problems. Seasonal affective disorder, breast cancer, Alzheimer's. There's people up at a number of hospitals. There's been an explosion in research related to lighting and how it affects brain chemistry. And ultimately, this long-term suppression of serotonin and melatonin has been shown to lead to cancer developments in people. So it's not good to get out of sync of your circadian rhythm for a long period of time. And really quick, just to sort of hammer this home, as architects, designing the environment for that we're going to spend 90% of our time in, that the public is going to spend 90% of its time in, that means we have a high level of responsibility for creating environments that are not going to be detrimental to people's well-being. And daylight can be an important part of maintaining that circadian cycle, that connection to the brightness and darkness cycle outside. And daylight is also a lot more than just light and brightness. It provides a strong connection to the outside, sort of an orientation to where you are in space and time and the time of year. And this is just a good example of that. This shows a Carnegie Library during the day, where you see these bright windows and sort of the rest of the interior darkens. But at night, as this thing sort of changes, you almost get a figure ground reversal. The windows go dark, the electric lights come on and really sort of illuminate this structure, show the detail. And you can imagine that this building has a life and a rhythm and a cycle and a dynamic nature that gives it a life that a lot of buildings that don't use light to their advantage don't have. We also know that if you spend long periods of time in a daylit in an environment where you're doing work, in computers especially, we all know what this is like. If you spend sort of 8 hours in a day or 10 hours in a day with your focus 18 inches away from the front of your nose. And that leads to all kinds of problems. And well-daylit environments provide a view and a connection to the outside. And that long, far-field focus is important. It allows your eyes to relax. It allows the muscles in your eyes to relax, and it allows you to be much more comfortable. And I like to show this slide. This is a project that I worked on about 8 years ago in Oregon. And the intentions were there. I mean, you can see this sort of light shelf. There's a lot of thought put into the daylighting and the sort of organization of this building. And it was a nice building. This was during a budget crisis. And we had sort of designed some workstations, and it was all going very well, and then they ran out of money. And they decided to drag their partitions from their old space into their new building. And this is what you got. And this, you sort of had this nice daylight distribution, but then someone brought in a 65-inch high partition and basically put all these people down in these little wells. So despite all the great intentions, this didn't succeed, in my opinion, in creating the highest quality visual environment. The other thing we know is that by design, architecture creates pollution through using lots and lots of energy. And daylight can help reduce energy usage in buildings if it's done right. But also has another quality that I think is nice compared to a lot of other types of energy efficiency strategies. Not only does it have the potential for creating a more energy efficient built environment, but it can do that at the same time you actually deliver a much higher quality space. I think that's unique in daylighting. But in some ways, it's sort of like trying to have our cake and eat it too. Though with the new technology we have in windows, in envelope design, in blinds and shades and exterior sun control, we can deliver daylit environments that are actually more energy efficient than buildings that are not well daylit. So how do we do that? Well, it's through sort of a simple line of thinking around creating small loads in buildings. And step one, in my opinion, I'm the daylighting guy, so I'm going to say this, of course, is to use daylight as the primary source of illumination in buildings whenever you can. And that's for most buildings. Optimizing the building orientation, shading the building skin. Don't overglaze. I think in most buildings, you can apply the same amount of glazing that you would in any other scenario and get effective daylighting. It just needs to be optimized, put in the right place, associated with the surfaces you're trying to illuminate. Here's a classroom. I just show this for example, where the glass area isn't substantially greater than in any other school that you would see. However, it's organized so that there's a relationship between these apertures, the interior surfaces. It's not overglazed at the perimeter to try to light the back of the space. They know that they can't do that without creating glare, and then they bring some light in to balance it on the backside, shape the interior of that thing, and just get beautiful illumination here. All the lights are off in this shot, and it just looks great. And then control electric lighting when daylight is present. This is a picture of the Herzog and de Meuron offices, and it just simply shows that this perimeter zone of fixtures is turned off. It's not necessary. And you guys don't know how much it drives me insane to see spaces daylight illuminated at 150-foot candles and all the lights on. So how do we do that? Well, we need to understand what our source is. If we're going to design a building that sort of responds to the sky as a light source, we need to understand what that light source is. And to make it simple, to make it sort of understandable, since the sky is so dynamic, changes color, the sun's in a different place, the weather changes, sites are different. We sort of break it up into two sort of simple categories. One is the overcast sky and one is the direct sun. And the overcast sky is really primarily a source from directly overhead, where the direct sun is this dynamic thing that is very difficult to respond to. How many of you guys, what do you guys think the percentage of overcast sky is in Boise? How much of the time is it overcast? Ballpark.
1/3.
1/3? A third?
15%.
15%. Based on this map, and this is created from TMY2 data, what I'm seeing is about between 150 and 180 days. So that's just slightly more than 50%. It seems pretty high. I was kind of surprised. Here's a cloud cover chart. And just to understand this, this is percentage in the vertical axis and time of year across the horizontal. So that's January, March, June. You guys have a remarkably similar pattern of cloud cover that we do in Seattle, where it's very likely to be cloudy in the winter and very likely to be sunny in the summer. The only difference is in Seattle, it's like 100% in those January times, and then that June period is more like 40. But this is a climate that maybe isn't ideally suited for passive solar. Maybe it is. I think there's certainly a passive solar resource. But it's a climate that in many ways is ideal for daylighting. And that's because based on this pattern of cloud cover, when the sun is very low and likely to be glary, it's overcast. So you get that glare control from the clouds. And when it's really high in the sky and most likely to create overheating, it's pretty easy to shade. Does that make sense? Logically? You know, in climates where it's the opposite, those are ideal passive solar climates where it's overcast in the summer, due to thunderstorms or for some other reason, and it's really sunny in the winter, so you can take advantage of that thermal load. Anyway, in Boise, you guys have an ideal climate for daylighting, and you have a much brighter resource than we do here in Seattle. So how do you daylight? Pardon? Oh, I thought there was a question. So in terms of delivering light, both in the overcast sky and in direct sun, the best way to bring in light in a controlled way is from directly overhead, if you can do it. And this is a slide from the Madrid library. And you've got these big, enormous, translucent skylights that sort of just light this space beautifully from above. You're not trying to push light in from the side or open up to lots of sun angles. It's just diffuse light from above. And you can see that the sectional geometry of this library is basically a diagram of the light distribution coming out of those things. And per this photograph, it's really, really effective. No lights are on. Just a beautiful, sort of simple idea about bringing in light from above. And as it's been in the past, it shall be in the future. The sky hasn't changed much. A thin building plan where you're out at the perimeter gives you access to daylight as a resource from the side. And then if you've got a big and deep building, bring in light from above. It's not rocket science. Daylighting in the direct sun, however, kind of is. It's really hard. It's complex. We've got essentially a point source, the sun. And not only do we have a very harsh point source, you can see in direct sun we have 15,000 foot candles. Out here you probably have closer to 20 in the summer. In shadow, that can be as low as 500. So the blue sky is actually really quite dark as a light resource. And not only do we have a very high contrast point source, that piece of that point source is at a different place in the sky every day of the week, every month of the year, every season. And it changes, it comes and goes based on weather patterns. So it's very, very dynamic. So how do we deal with that level of dynamism with something like a building, which is generally a fixed object? Well, it's tough. And the way we start to do that is to look for patterns in the sun's position in the sky. And the first thing we'll notice, this is sort of, does this diagram make sense to everybody? I'm sure you guys have all seen these thousands of times. Tell me to pick up the pace if I'm getting boring. But what we see is we've got this sort of low angle sun in the east, we've got this low angle sun in the west, we've got almost no sun in the north, and then the sun is in a pretty static position in the sky on the south side. So what we know is that east and west are difficult every day. North is really not that difficult, but we've got low illumination levels because we don't have a lot of sun there. And south is something fairly controllable, though we might have some seasonal problems with low angle sun based on your latitude. Look at this diagram this guy's holding here. I'm going to jump forward. See if I can get this to work. The other thing is, we can sort of look at diagrams all day and sort of figure out this is the sun, this is what it's doing. Let's keep our fingers crossed for technical effectiveness. I think it's really, really crucial as designers to keep in the back of our mind the reality of the experience of this. Because ultimately that's what we're designing, for an interior experience. And the experience of being in spaces with direct sun is interesting. It's sort of dynamic. You've got these patterns of direct sun that move around the space, changing distribution, and then ultimately the sun drops low enough that when you get it in your line of sight, it becomes extremely bright. So I want to sort of drill home the point that, yeah, it may not be that bad to sort of look at patterns of direct sun. It's dynamic, it's interesting, it can be very dramatic in the right space. But ultimately, the experience of being in this piece of sunlight is this. Here it's our turn to be in that patch of sunlight. So we know that it's very glary. So we need to be very, very careful about how we use it. And its distribution is wild. It's one of those things that connects us to what's wild in the world. I asked you to remember this diagram here. Well, this is a flattened out version of it. Everybody's seen one of these. This shows the position of the sun in the sky. And I really like these diagrams because to me, they're very informative and they're intuitive. So in the summertime, the sun rises. This is the bearing angle south. This is at noon, east, west. The sun's sort of rising out here in the east. These numbers indicate the time of day. And we sort of hit noon, and then it drops down, and it moves into the western sky and all that. So we could look at that and sort of understand bearing angle and altitude angle of the sun. But for me, that's not the point of showing this slide. The reason I show this is because it allows us to start to understand when we want to shade the building on the exterior and when we want to provide glare control on the interior. Because those glare control and solar shading are two sort of related but distinctly different activities. And a lot of times when they get conflated together, it results in buildings that don't perform very well because people don't take into account the fact that during all occupied hours you need to control glare. Whereas only during seasonal overheating do you need to control direct sunlight for thermal. And what is plotted on this chart is the relationship between the outdoor air temperature and the position of the sun. And why that's informative is we can look at the times of year that it's hot outside and know that we really want to shade that sunlight outside the building envelope. And know that periods when it's cool outside, maybe we want to provide our glare control on the interior. And that starts to give us a hierarchy for how we're going to address solar shading and glare control. That seems to be something that doesn't succeed frequently in buildings that I've been involved in. You know, whenever you talk about daylighting in the direct sun, the best person to, I always reach for Alto. It's easy. He's a master. It's just there for the taking. And I always like to remind people through that video that trying to daylight, trying to provide sort of a functional diffuse illumination with direct sun is like trying to drink from a fire hose. It's not easy because the sun is so intense. But Alto does a really good job of finding a way to take direct sunlight and turn it into something that we can use as a functional interior illumination source. And he does that by sort of designing the building as a light fixture. You guys have all heard it. It's pretty cliche, but in this case, it's the truth. And to be totally blunt, maybe it goes a little too far because to my eye, this is sort of a clunky exterior. However, the relationship to the sun is beyond dispute. You heard me talk about sort of the position of the sun and where are challenges and where are opportunities. Well, Alto takes care of them all here. The first thing he does is he stretches out his building long in the east-west direction because we know we've got that low-angle sun first thing in the morning, low-angle sun in the afternoon. And by making his building long and thin, it makes it shallow, it makes it exposed to the north where we don't have glare problems, and exposed to the south where we can control that sunlight. And the first thing he does after he stretches that building out is he just makes the east and west opaque and just takes that whole issue right off the table. We don't have to worry about low angle sun at all because it's not going to be affecting us. Then secondly, what he does is he sort of creates this reading room that literally traces the arc of the sun's position during the time of year that this building is going to be occupied and the time of day. Does that make sense? This is sort of south in plan. I'm trying to point with the pointer for all the folks on the internet. So this reading room traces the arc of the sun's movement across the sky during the time that this building is occupied. And it sort of is brought through a series of dilutions to make it useful. The first thing we see is that there's these fixed exterior louvers that are designed at an angle that never let direct sunlight down onto the floor. They essentially redirect them up onto this surface, which is right here in section. So you can see the sunlight hits there and goes here, and then ultimately is sort of pushed in a diffuse ball down into this space between the stacks. And you'll note that the stacks are perpendicular to the aperture so they don't cast shadows into the space. Secondly, Alto knows that if he creates this clerestory and sort of drives light into the space here, well, where's the darkest space going to be? It's actually going to be right here adjacent to that clerestory. So there's going to be a high contrast between that upper window and that wall below it. So this piece of the section redirects that light onto that interior surface, brightening this space and providing functional daylight down there. So he's sort of taken what was a harsh sunlight beam across a wide range of angles and turned it into diffuse light. But he doesn't stop there. He sort of knows that if he just lights this perimeter, it's going to be like a cave. Your eye always adjusts to the brightest location of a space. And if that happens, and this space is quite dark, and we've got daylight level illumination out here, the rest of the space is going to feel very dark, and it's going to feel contrasty. So what Alto does is he sort of punches a little hole on the north side to bring in balancing illumination. And not only does he do that, is he directly engages it with this surface here, which is deliberately shaped to sort of accept that light and provide a surface for it to be revealed on. And the relationship between these apertures and the surfaces is extremely sophisticated, so that the distribution of light is always balanced, always sort of connected with the task and the way that people perceive this space. So that's all I have to say about direct sunlight. All I have to do is go to Alto and it's sort of done. We've got a real big problem in terms of designing for daylight. We've spent the last 85 years with our lighting criteria being essentially only concerned with electric lighting. And there's books and books and books of reference manuals that tell us sort of how to do that. What do we have for daylighting? Well, we have one sort of 3-page leaflet in the LEED handbook. Certainly there's textbooks out there, but in terms of sort of widely recognized performance metrics, all we have is that. And it's tough because all of those lighting metrics are sort of designed around a static lighting condition, sort of generally between 30 and 50 foot candles, or 300 and 500 lux. But our daylighting resource is extremely dynamic. You know, it's all over the place, really high, really low. So how do we deal with that? Well, it's tough. It's not easy. I don't have any answers, so there you have it. We're working on it. But what's very clear is that what we've got for criteria now is not adequate. We see that based on the IES, or the Illuminating Engineering Society's recommendations for visual comfort, we've got sort of a maximum 1:10 contrast ratio in this workstation. But here's my workstation, and my space has a window. This is my old desk. This was on an overcast sky day in Seattle, and you'll have to take my word for it that it was entirely comfortable. It was just fine. And we sort of, this is measured in candela per meter squared, or surface brightness. And you see sort of 50 candela per meter squared at my desk, almost 20 on, down here. You know, this thing is a little bright, this task lamp. Outside in the sky, this is on the overcast sky, we have about 3,500. And that's a contrast ratio of 180 to 1. And anywhere you have windows, you're going to see contrast ratios in that range. It's just a fact of life, and it's something we've ignored, so we don't really know what the actual threshold is for visual comfort. And my guess, I'm just guessing here, is that there isn't any absolute numbers associated with visual comfort. It's going to be context-based. So when we look at LEED, as a metric. It's sort of our primary design metric these days. Its goal is to essentially provide building occupants a connection between the indoor spaces and the outdoors through the introduction of daylight and views in the regularly occupied spaces of the building. I think that's a really laudable goal. It's a good idea, and it's rightly placed in the indoor environmental quality portion of LEED, because that is, I think, the most important reason for using daylight, not in energy. And frankly, if you get the daylighting right, your energy credits will accrue based on that performance. But the ways that it asks us to comply with their credit are frankly lacking. We've got the calculation method, which, has anybody done LEED compliance for daylighting before? So everybody sort of has probably done this one. This is the one I recommend people to do because it's the easiest, especially if you're already doing a reasonable analysis. And this is sort of just a simple window to wall ratio that tells you when you've achieved a reasonable window to wall ratio for daylight performance. The challenge with that is that the window to wall ratio that achieves a good quality daylit space according to this option is the same in Nome as it is in Miami or Arizona or New York or here. And we know that those climates really require different architectural strategies. So it attempts to be a one-size-fits-all. It's based on the overcast sky, so it doesn't make a lot of sense. The second option is to do a simulation at noon on a sunny day and achieve more than 25 foot candles on a horizontal surface. But I find that a little problematic too, because one, what's magic about 25 foot candles? And two, what if you have 10,000 foot candles? You comply with the credit. It's just fine. And what if you're just sort of on the edge on the east and west? We know there's not a lot of illumination on the east and west at noon on the equinox because the sun is directly out of the south and you're going to be in shadow. So maybe do you bump those up unnecessarily to the detriment of the project to meet the credit? I would hope not. I certainly would hope the credit wouldn't drive anyone to do that, but stranger things have happened. The third one is even, actually, I'll back up. I like the intent of the third one. I think it's really important. It says you go out after you build a building and you go out and measure and see how it's performing. So it tells you you can go out and on a 10-foot grid, measure all your regularly occupied spaces and achieve 25-foot candles. So to me, it's sort of the wing and a prayer method. But it doesn't say anything about the time of day you go out there, or the time of year, or any of that. So if you have a building that you're sort of not entirely confident is going to perform per the credit, what I would do is get your light meter and pack a lunch and find a sunny day in the winter and go out and start with the east side. And you'll get your 25-foot candles pretty much everywhere. And then around noon, maybe make your way over to the south. And then late in the day, move around to the west side and sort of follow that illumination. I bet you can get there. Again, there's no distinction for what's too much, what's too little. But the one thing that I like most about the LEED credit, and I think this is probably, to me, its most important function, is it forces you as a designer to sit down with the brief and decide what spaces are important for critical visual tasks and where daylight is important. And in my experience, the most effective projects have been the ones where, prior to organizing the building on the site, lighting and daylighting and energy were part of the building program and had an influence on the building organization. And I think it's important for all of you, when you're designing a building brand new, to go through and look. If you want the daylighting to be good, go space by space and identify, are views important? Is daylight even important in these spaces? How often is it occupied? And what time of day and what time of year is it going to be occupied? And for those spaces that are going to be daylit, ask these questions. What are the minimum requirements? Is glare control important? You know, are there maximum light requirements? What might be a good solar orientation based on the time of occupancy? And what daylighting strategies in particular might be most appropriate? And I like doing that in conjunction with a program like this that starts to show a little bit about what the aspect ratio and sectional geometry of the spaces are going to be. Because that's, rather than sort of knowing gross square footage numbers, here you start to know a little bit about what the geometry of these spaces are and how the daylight might effectively be delivered. In this case, we sort of went through, and this is a very simplified version of what we did, but we looked at, say, the classrooms, and we know that these are sort of 30 by 30 spaces, and that generally, if they're not shallower than about 20, if they're deeper than 24 feet, we can't really effectively light them from one side. We have to light them from two sides. We also know that glare control and views are really important because of research that tells us that views are important in classrooms and because what we know about glare and direct sunlight. The other thing we know is that schools sort of operate from about 7 in the morning till about 2 in the afternoon, maybe 2:30, maybe 3 at the latest. So an east-facing classroom is going to be subject to very low-angle sunlight every day, first thing, and the teachers are going to close the blinds and they're going to stay down forever. But we also know that the west side maybe isn't that big of a deal because we can shade it and probably control direct sun easily until 3 o'clock. And if there's glare and maybe a little overheating, is it really a big deal if no one's there to experience it? So there are opportunities for site planning this thing. We know that the classrooms need to sort of be north, south, or maybe west, but certainly not east. And that it would be nice if they're not shallow, that they're also on the top floor. The gym is sort of a different story. It's lit from above. We know that we can't really effectively light a gym from the side without overglazing the heck out of it and making it subject to lots and lots of direct sun that's going to be glary. So ideally, that gym really wants to be directly under a roof so that we can light it diffusely from overhead. And that in reality, my experience shows that having windows or substantial amounts of window area just leads to lots of glare, and that most gyms with windows have the blinds pulled all the time. And that opens some opportunities. Yeah, it needs to be on the top floor, but in our worst case scenario, if we don't have a lot of windows, we can orient this thing east, west. We can put it in our worst location for sun angles because we're not going to be using glazing on the side. So the orientation of that thing really doesn't matter as long as it's got access to the roof. And the same could be said for some of these shops. They're getting big enough that we can't really effectively light them from the side. The theater, just like that historic example that I showed in the beginning, we don't want daylight in there. And setting priorities and identifying where daylight isn't important is just as illuminating and helpful in basic building planning as knowing where we want it, because it allows us to have priorities. Because if everything's a priority, you all know nothing is a priority. And then our circulation. It's not a critical visual task area, but sure, it'd be nice to have daylight in the space. So what we know is, let's orient it any direction we really want. Put some glass in there, make it nice, but we don't have to care if it's west facing or east facing. A little sun in there will animate it. It'll be cool. It'll be dynamic. And you know, you don't need a lot of glare control. So those can sort of fit in anywhere. And that, you know, is really been that exercise, even as simple as this, has been the difference in my experience between projects that sort of are an easy coast downhill to success and sort of an uphill, painful slog to mediocrity. It's just been my experience. So how do we deliver daylight? Well, predominantly through two design strategies, top lighting and side lighting. And top lighting, just like the overcast sky, it's easy. Skylights. high interior reflectances, bounce that light around. How do we know how much? Well, there's tools online like SkyCalc. There's sort of local lore that you guys probably know of how to do skylighting. It's very, very simple. The only design guidance that I have is generally I like the skylight spacing to be roughly equivalent to the floor to ceiling height, and I like about half that distance at the perimeter, because I know that if you light the walls, light the architecture, you get the perception of brightness. If you light the floor, you don't. So you like to get that light on the vertical surfaces. The other thing that is absolutely key is maintaining effective light diffusion. This is for a project I did for Boeing. This is, the bottom of the truss is 100 feet here. This is enormous. So here we've got direct sun just tracking through this thing. Looks like Studio 54 in there.
6, 7, 8, 9.
And though it's dramatic, and though it's kind of cool to look at, it doesn't fit the visual tasks that are happening in here. So yeah, it's cool, but the light's all over the place. The distribution changes. We got line of sight to the disk of the sun, and we've got glare. They've also got offices built in this giant truss. These are each a one-story office in here. And this skylight sort of drives direct sun and glare into those offices. Well, through just changing the materiality of that skylight to something light diffusing, we get an entirely different pattern of light distribution in the space. This is just the only difference here is diffusion. And it sort of ramps up, gives us a good distribution, and ramps back down.
7, 8, 9.
So it adds some dynamism, it gives some better color rendering, and it provides the kind of light diffusion that we need for putting wires together and riveting together aircraft. So how do we get that? We all know this stuff through pigment, fibers, scattering, cal wall, etc., acrylics. We can also get diffusion through refraction, the prismatics. I'm not going to go into the physics of light here. And then through reflection, just bringing direct sun onto surfaces and allowing that to diffuse through the space. I have until 6, right? Is that right? Do you guys need a break? You guys want to take a break? Questions, comments? Okay. Side lighting is really a much more dramatic challenge. It's sort of stuck with these immutable laws that you just never can get beyond. And that is that you generally get a distribution about twice the head height of the window. And that holds fast. And as soon as you get anything that vertically projects into the space, you get deep shadowing. And that's a challenge when you're trying to sort of fit out a space. And the other thing is that this is sort of the best case scenario potential. When the users come in and start changing the blinds, adjusting the glare, and putting their stuff in there, that's a whole different story. So it's very unpredictable. When you're lighting from above and you've got diffuse skylights, that sort of happens independent of people's interaction. Side lighting, you need to either be clairvoyant to your user activity, or you've got to plan for your worst case scenario contingency. And really to have effective side lighting in spaces that are this deep, essentially beyond sort of 25 or 30 feet, you really need a secondary source. It's just immutable law of physics. It's unforgiving. And I made this 40 feet because of something that I'm sure you all are aware of. When you're working with developers, what's the sort of magic number of that least span? Sort of 40 feet. Everybody needs to hit that because that's the economics. It's tough. It's tough. I don't have easy answers. One of the reasons that side lighting is so challenging is because it's intertwined with our desire to have views to the exterior. And we all love views to the exterior, but when we're bringing in light at the same time through that same aperture, the sun might have something to say about that. delivering light and providing views are both effective from side lighting, but not at the same time. They can sort of be at cross purposes quite a bit. And the other thing that's absolutely key in designing with side lighting is, frankly and oddly, when you, at first blush, the position of the back wall. Because as this back wall starts to drift away, you start to get this cave effect. I show this because this is where sort of the edge of the proportion of where you can side light a space and have nice balanced illumination from the perimeter to the interior. As this wall starts moving back 3, 4, 5, 10 more feet, you lose the surface brightness on this wall. It starts to get dark, or it starts to have shadows on the top of it. And the perimeter to interior relationship starts to get contrasty, and we know that that creates glare. And one of the biggest problems with side lighting in my efforts has been, well, we've got a 34 or 32 foot deep space, and we're going to try to light it from the side by throwing light shelves and throwing huge amounts of glass out at the perimeter to sort of drive that light deep into the space. And I've heard a lot of architects sort of use that as their reason for doing all glass facades. But the problem is, in trying to deliver light deep into the space from the perimeter, all you do is end up overlighting this space, opening this perimeter zone to more glare, and increasing the likelihood that the occupants are going to close those blinds. So it doesn't really pay to overlight this zone in a pretty futile attempt to get light into the back of the space. The only way to really make that happen effectively is with a second source of some sort, either from the top or from the other side, and that's tricky. So how do we deal with that as best as we can? Well, going from the outside to the inside, you heard at the beginning, or 15 minutes in, I showed that diagram with the sun and its position relative to outdoor air temperature. That can guide us in making decisions about how we want to shade. Because if you shade on the outside, obviously, you're going to have much lower thermal loads on the interior. And that's going to be much more effective. And this just shows the difference between shading with some exterior Venetian blinds versus no shading at all. And it's substantial reductions of IR, infrared radiation. So in some respects, automated exterior louver blinds are sort of the magic bullet, because they shade the sun when it's there, they can automatically adjust to the tilt angle, and then when the sun is gone from that facade, they go away and allow the maximum diffusion of light into that space. Or when it's overcast, they allow the maximum diffusion of light into that space. And the sun's not a mystery. We know where it's going to be, so these can be programmed based on an astronomical time clock and only controlled based on the presence or absence of the overcast. Secondly, we can sort of do fixed exterior architectural shading and design that to sort of shade the window around the time period when the building is likely to be in cooling mode. And that's pretty simple in our climate. I mean, you get about a 1-to-1 relationship between the shade and the glazing beneath it facing south, and you'll get pretty much complete sun control from March 21st through the summer to September 21st, and that can be pretty effective. In the glass layer, we just need to understand the properties. I'm sure you're all well versed in this, so I'm not going to go in detail. Solar heat gain versus visible light versus U value. Suffice it to say that the sort of golden property is in daylighting is the LSG, or light to solar heat gain ratio, and then obviously U value is what makes your envelope tick. I put this in as a reminder. With these kind of blinds, they're nice, they provide darkening, but as soon as the sun drops into your field of vision, even at 98% opaque, it's uncomfortable. And we've learned that. We actually have had to install a second set of blackout blinds to control that. So roll-down fabric shades are good for darkening. They can be good for solar heat gain control to some degree, for radiant heat. However, they're not foolproof in terms of glare control. To do that, you really need something that is completely opaque. And if you want to maintain daylight performance, you need to do it with something that has some characteristics of light distribution. So I like this slide because it shows that all that direct sun has been blocked because there's shadow, yet we still have the redirection of diffuse daylight up onto that ceiling and ultimately into the space. This is from the Genzyme building. These images are from Varema, a German high-tech blind manufacturer. And they make some interesting sort of daylight optimized blinds that help you sort of allow glare control without sacrificing daylight performance to a large degree. The perennial problem is that people close their blinds and then you get no benefit out of all that glass. You get no daylight benefit. So that's a sort of sketch of the challenge and some of the potential opportunities. I want to show you a few slides of some projects that I've worked on over the past 4 or 5 years that have gotten built. And Kevin and I, actually one of the reasons Kevin flew me out here is to do double duty, helping him photograph some buildings here in town. And what we've been doing is finding projects that we think turned out pretty well, that the occupants and the owners think turned out pretty well, and going and looking and turning the lights off and using a process called high dynamic range photography to capture the pattern of daylight distribution in the space so that we actually understand, is it doing what we thought it was going to do? Is it effective? Is it functional? And I'm going to show you some buildings. I showed in my slides some buildings that had some problems, and these are all projects that I think are pretty good. The first one is the Terry Avenue office building by Weber and Thompson. And this building just this week was named a AIA National Committee on the Environment Top 10 Green Buildings. So that was kind of an honor here. And this is sort of this is a little ironic because Weber and Thompson is a developer in Seattle, or they're sort of the architectural arm of a development group in Seattle. But for their own building, they decided to sort of bite the bullet and break some of the economic rules that govern building geometry. And really, at the outset of their design process, since it was for them, their staff sort of came to the decision that their two big priorities for this project were daylight and natural ventilation. And even when they found out, sometimes it might be a little glary, sometimes it might be a little hot, sometimes it might be a little cold, they decided they were going to live with it. So they really pushed this stuff to the edge. And this is just a diagram of our daylighting model. This is sort of the shape of the building, and you can see that a big piece of it is missing in the middle. And here's some sections of of the project, and you can see that they're sort of the same. And as you descend into this, the atrium's on the left-hand side. So the perimeter daylighting stays the same. The inside sort of is similar to the perimeter at the top and then gets reduced as you go down. And you can see here the bottom achieves anything that's blue is below our criteria. It starts to drop below, but then at the bottom it bounces back up. And the reason for that is the floor-to-floor height on that bottom floor is 16 feet because we just couldn't get enough light in from the side in the atrium to make it work on the bottom, so we had to bump the building up, and in the end it made it for a better retail environment, so we had some tailwind there. So here's a photograph of the finished building. It's in an area of Seattle called South Lake Union, developed by our benefactor Paul Allen. So the big move here, this building is simple in a lot of ways, and its big move is essentially having a floor plate that's never more than 15 feet from the perimeter. It's sort of like that first building I showed. It's just a back to the future kind of design with this beautiful atrium in the middle. And they've sort of put stuff in there and enlivened it a little bit since this photograph has been taken. But in the end, that's a pretty simple move. It's just hard to make happen. Where does all the circulation go? Where does the core stuff go? And what the heck happened to all my leasable square footage? But again, they're the owner, so they felt comfortable doing that. So here's the space with all the electric lights turned off on a sunny day. And the atrium is to the south, and the sun is it's around noontime, so the sun's coming in. There's some external Venetian blinds that block that direct sun and limit it to this zone, limit it to the circulation zone. Another thing you'll notice is that, one, just how remarkably thin this space is and how high the internal reflectances are to maintain that perception of brightness relative to all those views to the exterior. And secondly, the partitions are very light colored, they're very low. The stuff that's perpendicular to daylight apertures is generally transparent. So this thing really has a distinct relationship, one, to the sky, two, to the site in sort of the building geometry and how that delivers apertures, and those apertures relation to the floor plate, the relationship of the apertures to the sun control, to the interior surfaces, to the workstations, and ultimately to the sort of basic ergonomics of how they set that up and face people. And what I've noticed is that any daylighting design is really only as good as the weakest link of that whole chain of activity. And it's hard. It's hard to make all that stuff work. But in this case, they did a pretty good job of it. Here's a shot. We sort of just pan to the left here and look out at the sunshade that's controlling the direct sun that's going into that little circulation area. So this is the exterior Venetian blinds. And they're out on a little sort of aluminum aperture. Here's a picture of their gallery space looking out into that atrium. And one of the things you'll notice is that the sort of views aren't really blown out. And that's because there's a sort of natural balance between the outdoor illumination levels and the indoor illumination levels, and they're sort of kept at a proportion that can be really effective. Here's an upper floor office, just showing the nice, again, balance from one side to the other. You can see the blinds out there. Here's their little staff break area. Again, all these images are with the electric lights off, except you can see there's some task illumination happening. But this is the atrium off in the distance. And then here's that lower floor with the high floor-to-floor height. And you can see, in fact, it does get quite dark back here where the atrium isn't, and where the windows become more punched openings instead of this north-facing deal. But all in all, from a daylighting perspective, this was a project where we were sort of allowed in, and nobody resisted. And it sort of shows. I mean, this building's kind of all about daylighting and to some degree natural ventilation. So for me, that's pretty cool. But they seem to be pretty happy with it too. Here's another project. This is a project we did with Miller Hull a few years back. And ultimately, what's interesting here is how they addressed the site and how the section of this building dealt with issues of sun control, building massing, deep floor plates, and space planning. This is the Kitsap County Administration Building in Port Orchard, Washington. And to the right is north. To the left is north. So this building sort of goes downhill to the water to the north, and to the right is south. So here's the sort of entry. This is the little interior courtyard. Beautiful space with a view out to Budd Inlet, if anybody knows the area around Bremerton and Port Orchard. Here's the upper floor office, and this is the only space that's sort of lit from two sides on the perimeter. This is at the very top of the sort of building massing that cascades down the hill. And on the left here is our, I'm gonna go to the next slide. I like this one better. On the left here is the north. On the right is the south, and this is a south-facing clerestory. And then there's views to the outside through the council chambers offices here. And the thing that works well about this is there's no direct sun out of the north, so these views are nice and clean, no blind control problems. And our south window has a little overhang, but it lets direct sun in the winter. But architecturally, what they did was they space planned this sort of copy room, utility room bar adjacent to the south and put a hard lid on it so that when the sun comes in, it never penetrates deeper than the hard lid here. So it never actually gets in this space and causes glare problems. So they don't have to go up and control blinds up there, which is really nice. Again, all the electric lights are on except this sort of desk light here. And this just sort of shows another view of that, showing how these office workstations, though they're in the center of the space, still have that nice line of sight out to this spectacular view. Here's a lower floor. We're sort of starting to get cascade down that hill. And what we see is where we've got the deep floor plate, they put in a skylight. And it's actually a transparent skylight, which in a lot of projects would cause problems. But it's a budding north-facing building mass. So no direct sun goes through this building and enters the space until the sun swings around to the west, essentially behind where we're looking. And at that point, it slices through but never leaves this circulation way. So it's not really a problem in their visual task areas, which was really a smart thing. Here shows the sort of knuckle between how this thing cascades down the hill to the, so you see the skylight we were just looking at over here. This is the view. Here's a green roof of the office bay below, and here's the skylight into the next bay. So you can see how this piece of building mass shades the skylight, gives a nice view to the exterior and that thing, and also provides nice daylight with no sun control problems because it's all north facing. So this just sort of shows how this thing kind of moves down the hill. Does anybody know of Henry Klein Partnership in Bellingham? This is an architecture firm that does a lot of campus buildings. And they were selected to do the Morse Center, which was actually sort of it was at Bellingham Technical College. And I don't mean this in a bad way, but this is a great example of how a simple idea and a sort of dumb box can become a really beautiful, elegant design on a number of levels. But I'm going to talk about the daylighting, obviously. This is their shop. This is their welding shop with all the electric lights off. And the only thing they do here, their entire daylighting strategy is essentially just big cow wall skylights. And it's not just that they're sort of dumping light onto the floor here. You'll notice that there's a careful relationship between the primary vertical surfaces and the sort of edges of this architectural enclosure and the placement of skylights. So here's their big shop, just amazingly daylit space, and it sort of spills out to the outside. Here's their welding apparatus bay, and this skylight here, this cow wall skylight, sort of delivers functional light onto these benches, but it also serves to light this wall. And its relationship to the wall really creates the perception of brightness and sort of animates this, what would otherwise be sort of a dull interior box. And then they've got these big welding bays, sort of where they teach students and teachers go in and sort of weld in these things. And they've got this upper volume that's all painted out white and these big skylights. And we looked carefully at the sort of relationship between these welding bays and the skylights and how light distribution was going to happen. And there's no top on them. So you get this beautifully daylit space, and if it's sort of a dark day, you've got this. But it's just simple, dumb, diffuse light placed to light the architecture. You know, lighting design can sort of be simple and just driving light onto the floor, and it's not very interesting. Daylighting can be the same way, but if you sort of place this sources of illumination thoughtfully relative to the surface, you can create amazing spaces out of what would be sort of dull. This is their auto shop. Same strategy. We've got some acoustic panels that pick up brightness on the walls. This is the only space that isn't really well daylit is their auto body painting and grinding area, because that needed an enclosure for toxicity. But just again, a beautiful space. And I think I'm going to end with this project here. This is a project I worked on with Methuen Architects. This is the Novelty Hill Winery. And I also collaborated with G.Z. Brown, or Charlie Brown, at the University of Oregon, who's the author of Sun, Wind, and Light, and really sort of a legend from the 70s and beyond in passive design. He's been sort of at this longer than I've been alive. And he did energy programming, and I collaborated with him and Methuen to do sort of programmatic analysis of the daylight and the lighting needs. And it's simple, and I think it underscores the issue that daylighting, just like electric lighting and other design, isn't a one-size-fits-all activity. It's something that needs to be appropriate to what's happening in the space. And there's really two spaces. This is a space where people go and visit and taste wine and have weddings and do all sorts of things. And there's sort of a retail experiential place. And then there's really more of a critical visual task area where they sort of do wine making and have their studio. But the idea was to have a strong connection between the two of those through transparent glazing and other things. And we did a few things to make that happen. So here's a nice shot of it. It's cool, sort of slick contemporary architecture on top of all these good ideas. Here's their bocce court. If you guys ever get out to Woodinville in east of Seattle, this is a cool winery, and if you're into architecture, you'll be into the building too. Here's another image. I just show these because it's beautiful. So here's the interior. This is sort of where you go into the tasting area. And you see these skylights. And those skylights sort of animate these tilt-up concrete walls. And they're transparent. So you get little dashes of sunlight. You get diffuse light. It changes color. It just takes those concrete walls and turns them into a dramatic piece of art that's always changing. But your eye is always brought through the presence of this task lighting that's always on to this sort of transaction counter where you do your tasting, you sort of know the focus of the space. So as the daylight sort of dramatically changes on the walls and changes in terms of the horizontal illumination, these sort of these decorative light fixtures provide an anchor of stability in the sort of dynamism. And I think that's a really interesting thing because daylight doesn't do a good job of providing consistency or providing task illumination. But what it does do a good job of is providing ambient sort of dynamism. And in the background here, you can start to see a little bit into their barrel room in the back. Here's their function room. Again, light levels don't need to be high. All the electric lights are off, and same deal. We're sort of lighting that wall, lighting the vertical surfaces, and sort of letting the center of this space drift. Here's looking the other way out to the bocce court at some of the art on the wall that, again, is illuminated by the wall wash of the daylight. Here's their cafe, and again, there's no mystery about where the transactions happen here. This is their barrel room. And our energy analysis showed that since they're cooling this space, this envelope needs to be really, really tight. So they buried this up into the ground. They insulated the heck out of the walls, and they said, you know what? We want as little aperture as possible here. So we put in two skylights, one that grazes the face of the barrels and one that lights the back of the space. And because right behind us, up above, is that tasting room. Oh, sorry. You can see it here. So you look down into that barrel room, and since they were both daylit, if we had to light a few surfaces to allow that visual transparency so we could see into that space. And it was very minimal. It wasn't about delivering functional illumination. It was about just sort of providing enough light on the right surfaces to sort of key in that transparency. Because in reality, one, people don't go in there very much. So high quality daylight wasn't key. And two, when they're in there, they're generally using a forklift, which has its own headlamp. So daylight wasn't really that important for any other reason than experience. And that sort of worked with the energy goals of a tight envelope and a heavily insulated space, because they maintain this thing at about 10 degrees C, or like 45, 50 degrees. But the other side of that wall is where their winemaker studio is. And we really designed this space, sort of essentially engineered it to just deliver diffuse daylight through skylights. Put a lot of them in there, coordinated it with the sort of FF&E build out of all these items, and got some light on the walls, and made it so that there was very high quality color rendering, high levels of illumination that were appropriate to reading their gauges, working their bottling equipment, and doing all of that. And so the point being that each one of these spaces sort of has a different daylighting strategy, and that strategy sort of rolls out of the function, the tasks, the goals for the space. And it's not a one-size-fits-all thing. It's really driven by a multitude of different ideas about space and light. And that's all I have to say. I'm done. Thank you all for being. You had a question? They are transparent, but they shouldn't be. Yeah, I wasn't happy about that. They thought there was someone that just had to see the sky. And it's been a little bit of a problem, because what happens is sometimes when there's direct sun, you get sunlight on a temperature gauge, and it cranks it up to about 170 degrees, and they're bottling. Their tank room needs to be a highly controlled condition. So I'm not sure if they've gone in and fixed that yet, but it's been talked about. Anybody else have comments, questions? Want to challenge? Yeah. Thanks for being patient. I know it's kind of long to go an hour and a half without a break, and sort of I went fast. So.
Well, that was a lot of information. No last minute questions? Are you sure? Anyone? Anyone? Thanks, Chris. That was excellent. I love these pictures at the end.
Yeah, yeah. Kevin's a big fan. Kevin and I have been working on a book together.
Thank you all for coming. Thanks to Idaho Power, Northwestern Energy, and Better Bricks, of course. Thanks, Chris, for coming out. And if you didn't sign in, please do. It's really important. I always say that. I always mean it. So please do sign in again. Thanks so much.